Okay, now I've got the line cord plugged in to the variac. Actually, it's a combination variac and isolation transformer. And I use this because it not only provides the ability to vary the AC voltage, but it also provides line isolation. So keeps the hot chassis sets from being as big a hazard. This isn't a hot chassis set, but anyway, let's try it. Turn it on. And I've got this set to measure amperage. And of course down here I have this meter plugged in to pins 4 and 6, which is the high voltage AC. So what I'm going to do is I'll pull back here where you can kind of watch both at the same time. We'll raise this up, and you see we're starting to get some voltage. And you see that on the 1000 volt scale here, I'm getting about just over 600 volts high voltage there. So that means that the secondary is working fine, and it's only drawing about a little over a half an amp. So that's good. That basically means that the tube filaments are what's pulling most of that current. And as you can see over here, if I turn this light out, maybe you can see that the tube filaments are lighting up. There's one, and back in there you can see some. This one. Okay, next thing is to give this a kind of smoke test to see whether it looks like it might actually work. We now know that the filament windings are working, and we know that the high voltage winding works. So next, it's to find out whether or not the B+ will come up. Turn that on, and we'll turn this to standby, which should allow the filaments to come up, but should not produce any DC voltage. So now let's watch this to begin with. It's about 120 volts. And, whoops, I've got my meter connected backwards. So let me reverse that. Okay, I'm back with the leads connected the right way, with the red connected to the plus. And you see we're reading about 400 volts on pin 8 of the 5U4. Now right now, that standby switch is still open. Next thing we're going to do is close that switch, but we're not going to do that with full AC power applied. Instead, we're going to turn the AC power down to 0. Then we're going to turn the switch to on. And now we're going to bring the power up again. The reason is, if one of those filter capacitors is shorted, it's going to draw a lot more current. So now let's watch the current as we come up. Okay, we're near, see, it's drawing a lot more current now because it's probably charging. Yeah, you see, we now have only 200 volts on pin 8. Now let's go on up a little higher. About 120, and see we're drawing about 1.5 amps there, and we have about 310 or 320 volts on that position. Let's go to the 500 volt scale here and get a little more accurate reading. Yeah, about 300 and almost 304, about 340 volts, which is probably about right. What I'm going to do is I'm going to leave that there for a little while and let that form those capacitors. Now we're going to replace those capacitors eventually anyway. We just want to find out that the unit is worth rebuilding, restoring. And it looks like it is. There's no signs of smoking or overheating. So we'll kind of monitor this for a few minutes. And then we'll do a few more checks before we install that 6DQ6 and see what happens then. Okay, we've installed the 6DQ6, and I brought the voltage back up, and you notice that it's drawing a little over 1 amp. The high voltage is running about just over 300 instead of the 340, maybe 310 or so, which is normal now that it's drawing all of the tubes are conducting. However, it looks like that there's a raster on the screen right in there. Might be flickering a little bit. We can check that a little later. But what that indicates is that the high voltage section is working. High voltage rectifier, the horizontal and vertical output sections, the yoke, and all of that. Because of course, without yoke currents sweeping it in the horizontal and vertical direction, you only get a white dot in the center. And of course, without high voltage and the right currents on the pins of the flying spot scanner, you wouldn't get a display. So now what we have is at least the beginnings of a working unit. So it looks like this thing is certainly worth restoring, and given that it's one of the really rare pieces of B&K equipment, it dates back to the very early days of B&K. It's the first true television analyst. So I think the next thing we want to do is get in there and start rebuilding some of the circuitry with new components, better capacitors, things like that. And we'll pick up in the next video after we've done a little restoration.